Hello, can you hear me? Can you see my screen?
Yeah.
So let's start from for today's class. Today we will continue to learn chapter 12, section 2. This section we will learn some special triangles. You know, special triangle actually here, one it's called 30, 60, 90 right triangles. And also we will learn like isosceles triangles. And we also will learn the equilateral triangles. Now let's see the first example from problem 12.8. See this problem, DEF is a isosceles triangle. That means you have two sides are equal, right? So that's DE equals EF equals 26. And DF equals 20. A. Suppose M is on base DF such that EM is an altitude of isosceles triangle. Why must M be the middle point of DF? B. Find the area of DEF. So first, say for geometry problem, you need to draw a picture, draw a diagram. That will be help you a lot. Otherwise, you feel very confused. See, here we have two sides are equal. Okay, now let's set this one it's E, this one is D, this one is F, then D equals EF. This is 26, this also 26. Now DF, this one equals 20. Then they said M is on base DF such that EM is an altitude of isosceles triangle. So that means EM is perpendicular to DF, right? Something like this. Now we write here, this is perpendicular to DF and intersect with DF at M. Now first, they ask you why M should be the middle point of DF. So they ask you prove this one equals this, right? If M is middle point of DF, that means DM equals MF. So to prove this, first I'm thinking use congruent triangles. So in triangle DEM and FEM, we have D equals EF. They give us, right? Then the shared side EM, and also they give us EM is perpendicular with DF. So that means these two triangles are right triangles. Then, you know, in right triangles, we learn the theorem called HL theorem. H, that means hypotenuse. L means leg. That means in two triangles, two right triangles, if you have their legs, one pair of legs are congruent, and one pair of hypotenuse are congruent, then that means these two right triangles will congruent. So then by that way we can get these two triangles are congruent, then the DM will equals MF because these two side is corresponding sides, right? So then if we write this one, this proof out, you can just do this way. You can write like this. In triangle DEM and triangle FEM, okay, then DE equals EF. They give us this one equals 26, right? Then EM equals EM. This side shared. You can write like this way. Then EM perpendicular with DF. From this, you can get that means angle EMF equals angle EMD. This equals 90 degrees. Then combine these three conditions together. You can use theorem called HL. Because this one makes these two triangles are right triangles. Then you use HL theorem. You can prove these two triangles DEM congruent with triangle FEM. Then from this congruent triangles, you can get DM equals MF, because these two sides are corresponding sides. Then you can get M is middle point. M is the middle point of DF. Okay, I don't need to write that. Okay, so this is A, right? Now let's see, find the B, find the area of triangle DEF. To find the area of triangle DEF, you know area we use the square bracket of DEF. This one means area of triangle DEF. O equals 1/2 times base times DF times EM. So we know DF, that's 20. They give us this one's 20, but we don't know EM. So, but this one, it's a right triangle. The hypotenuse 26. So this DM will equals 10 because that's M is middle point. Then we can find this attitude. That will equals 26 square minus 10 square, then square root. This gives you the length of attitude. Then you simplify this. You can write this one that's 26 plus 10 and times 26 minus 10. So you get a 36 times 6. No, times, add it together, you get a 36. Minus, you get a 16. So this one square root, you get 6 times 4, that's equals 24. So that means 1/2 times 20 times 24. This one will give you 240, right? 20 divided by 2, that's 10 times 24. So the area of this triangle, that will equals 240, right? So by this way, we solve this problem. Now let's go to next one, to 12.9. So this problem, they ask you, suppose triangle ABC is an equilateral with side length 6. Find the length of attitude of the triangle ABC. Find the area of triangle ABC. Okay, this one is very important because this one you will use a lot of times. you see this problem will be a lot of times. Suppose this triangle ABC, it's equilateral, and they give you each side equals 6. Okay, these three sides, they are all equal. Then they ask you find the altitude. So if I draw the altitude from this vertex A to BC, then suppose they intersect at D, then how long is AD? To do that, based on the previous problem, when you draw altitude from A to BC, if this triangle is isosceles triangle, then you got this D will be the middle point of BC, right? Remember that just we finished that problem. So that means BD equals DC equals 3. So then in triangle ABD, this is a right triangle. ACD also is a right triangle. So then we can use Pascal's theorem. We can get AD equals AB square minus BD square, then square root. So then you plug in these numbers. That will be 6 square minus 3 square, then square root. So this one equals 36 minus 9, then square root. So this one equals 27 square root. So you got this one equals 3 times root 3. So this is the altitude, right? We got this one's altitude of this equilateral triangle. That's AD will equals 3 times root 3. Then they ask you to find the area of triangle ABC. So after you get the altitude, then the area will be very easy to calculate. You just use 1/2 times base times altitude. Then you can get the area. That's 1/2 times 6 times 6, then times 3 root 3. So we simplify, this one will be 9 times root 3. This one will be the area of this equilateral triangle. Now let's extend this problem a little bit further. Suppose we did not give you this specific number. Suppose we give you this as a length is A. Each side is A. Then what is the altitude of an equilateral triangle with the length side A? Okay, so if that's the case, then you can still do the similar way, but this time the Pascal's theorem will be here. Will be A squared minus half A, then this one squared, then square root, right? So each side is A. Then based on that, this D also will be the middle point of BC. We got that BD will equals A over 2. DC also equals A over 2. So then in triangle ABD, we use Pascal's theorem. We can get A squared minus A over 2, then square root. So this one, you can get A squared minus A squared over 4, then square root. So then you got this one, the 3A squared over 4, then square root. So continue simplify. This one will give you A times root 2 over 2, right? So that's also you can write root 3 over 2 times A. This one is altitude. It's better to memorize this one in your mind. Then later you don't need repeat this work at all. You know, you will see this kind of problem will be hundreds or thousands of times. They give you a equilateral triangle. Suppose each side maybe it's A, maybe use a letter B, maybe use X. Then you know the attitude of this equilateral triangle will equals root 3 over 2 times A times the side length. Root 3 over 2 times A. Then now let's calculate the area of this triangle if we only know the length is A, is not a specific number. So then you can still do 1/2 times A times root 3 over 2 times A. Then you can get this one equals root 3 over 4 then times A squared, right? So then we can check if we got this one is right. Now you can do prog A equals 6. Say if the answer we get is same as we calculated here before, right? If A equals 6, then this one will equals 3 times root 3. See, that's exact same with what we get here, right? Then you also can prog A equals 6 to here. Check if the area we get is same as the answer we got here. So A equals 3, that will be A squared, that will be, no, here A is 6. A squared, that will be 36. So root 3 over 4 times 36. So it cancels out. This will be 9 times root 3. See, exact same with what we got here. So then, say from this problem, you know, we get if each side of this equilateral triangle is A, then the attitude, usually we use H to represent. That means height equals root 3 over 2 times the length of the side. Then area, usually we use A or use S. Now here we use S. Of this triangle will equals root 3 over 4 times A squared. This one is a very important formula for equilateral triangle. How to get the attitude of an equilateral triangle. Equilateral triangle, you know, the three attitude is same, okay? So then we just get this number, that will be the attitude for this equilateral triangle. The area of equilateral triangle equals root 3 over 4 times side square, A squared. Okay, so this is problem 12.9. Now let's go to example 12.10. See this problem, if one leg of an axis right triangle has length 5, then what are the lengths of the other leg and the hypotenuse of the triangle? Everybody, can you send me your answer in the private chat? Now let me check if you got this one right. This one is very easy, but first try to draw a diagram. So what is axis right triangle looks like? You need to draw this. Otherwise, how you do the further calculation? So to draw this, say that means you have two sides of this right triangle. They're same. Okay. So now let's say, suppose this angle is a right angle. Then this side is A, this is B, this is C. So then only AB will equals BC. Now they give you one leg equals 5, so that means this leg is 5. This one also will equals 5 because this is an isosceles triangle. You know, hypotenuse always longer than the legs, right? Because the two legs, sum of two legs square, because you have this a square plus b square equals c square in a right triangle, right? So that means c squared definitely is greater than a square. C square is also greater than b square. So that means if one leg is 5, should be another leg also will be 5 in this isosceles right triangle. Then they ask you what is nuts of the other leg and the hypotenuse of the right of the triangle. So another leg definitely also will be 5, right? Then the hypotenuse, that will be, say, 5 times root 2. Why? Because you can do 5 square plus 5 square, then square root. So then we can take 5 square out to get 5, then times root 2. You can also calculate, say, 5 square equals 25, 25 plus 25, 50. You can write 50 is 25 times 2. You can take 25 out, you get a 5, then times root 2. This is a hypotenuse of this isosceles right triangle. We finished this A, right? Now let's see B. If one leg of isosceles right triangle has nuts 8, then what are the nuts of the other leg and the hypotenuse of the triangle? So now they said this one's not 5. They changed to 8. Now let's see, if this leg equals 8, then this leg also will equals 8. Then the hypotenuse will be 8 times root 2. If you don't believe, you can just calculate this. 8 square plus 8 square, then square root. This one will give you 8 times root 2. Right? Now C. If we know the nuts of the one leg of isosceles right triangle, then what is the faster way to find the nuts of the hypotenuse? So now that means if we give this side is not a specific number, let's give, suppose that's A, then the other leg also will be A, because this is an isosceles right triangle. Then the hypotenuse will equals root 2 times A. You know why? Because A square plus A square, then square root. So you get this one equals A times root 2, right? Take this A square out, you get A, then times 2. So this one, it's a formula to calculate the hypotenuse of equal it's a isosceles right triangle. That's root 2 times nuts of the leg. Okay, then now let's go to 12.11. See here, this is a special right triangle. We call that 30, 60, 40, 30, 60, 90 triangle. You know, for a right triangle, okay, now let's say this. Suppose this one, it's a right triangle, A, B, C. This angle, that's 90 degrees. This 90, suppose this one is 30. Then this one will equal 60 degrees, right? Because in a triangle, the sum of their three angles should equals 180. If this one is 30 and this is a right angle, then this angle will be 60 degrees. Now A, describe how to divide an equal or equilateral triangle into two identical 30, 60, 90 triangles. Okay, do you know how to do this? If we give you a equilateral triangle, suppose this one is an equilateral triangle, then they ask you how you can divide this equilateral triangle to the two 30, 60, 90 right triangles. Okay, this one is very easy. You just pick the middle point of one side of an equilateral triangle. Suppose we pick the middle point of BC. Suppose this point that's D. Then you connect it AD. Then this AD will separate this equilateral triangle ABC into two right triangles. Their angle is 30, 60, and 90. Right? You know why? Because this side equals this side, right? And we make this one equals this one. We take this D is middle point of BC. Then this side they shared. So these two triangle congruent. Congruent, that means this angle will equal this angle, and also this is a straight angle. So that means these two angles all equals 90 degrees. But also in a equilateral triangle, each angle should equal 60 degrees, right? Each angle is 60 degrees. Then you will get this angle will equals 30 degrees because this 90, this 60, definitely this angle will be 30. This also will be 30 degrees, right? So by this way, you separate a equilateral triangle to two right triangles with angles 30, 60, and 90. This is one way. Actually, you can also draw a perpendicular line from any point of this equilateral triangle. Suppose you draw a perpendicular line from A to BC. Then you get D. This D will overlap with this middle point D, right? Because say this will be exact same. So then you have these two ways to separate any equilateral triangle to two right triangles. Their angle should be 30, 60, and 90. Now let's see B. Suppose the leg opposite 30 degree angle in a 30, 60, 90 triangle has length 2. Suppose this one is 2. BC equals 2. Use your answer to part A to find the hypotenuse of the triangle. So if this BC equals 2, they ask you how long is AC. Okay. So this one, because in an equilateral triangle, we just connect the A with the middle point of BC, then we get these two right triangles. They are 30, 60, and 90 degrees, right? Then, now, if this BD equals 2, this DC also equals 2, that means the hypotenuse will be 4, right? See? Then, by this way, if we add another triangle with same triangle here, then you will get equilateral triangle, right? Suppose this one is A, B, C. This one's D. So this triangle will be a 30, 60, 90 degree right triangles. So by this way, you combine these two together, you get an equilateral triangle. So if this DC equals 2, here will be 2, that means the other two sides will equals 4. So by this way, we can get the hypotenuse of this special right triangle very easy. Just times 2 to this 30 angles opposite side length. Then you get the length of the hypotenuse. That's 4. Then if we extended this one further, suppose we give this one length that's A, then you'll get the hypotenuse length will be 2 times A. Then the height or the altitude of this equilateral triangle, or you can call this one is another leg of this triangle ABC, will equals 2A. You can get 2A parentheses square minus A square, then square root. This one you get root 3 times A. Okay, this will be the length of another leg. If you know the 30 degree angles opposite length equals A, then hypotenuse of this right triangle will equals 2 times A. Then another leg will equals root 3 times A. Okay, so now let's see C. Suppose, you see, we already get this B. They also ask you what is the length of another leg. That will equals root 3 times 2, right? Then C, suppose a leg opposite the 30 angle in a 30, 60, 90 triangle has a length S. Then they ask us, yeah, we already got this. This is the S. In terms of S, what are the lengths of the hypotenuse and the other leg of the triangle? That will be, hypotenuse will be 2 times S. Another leg will be root 3 times S, right? So we already got this. By this way, we already finished the example problems in this section. You know, your homework for this section, that will be behind this section. Now let's see how many problems here. That will be, let's see, 12.2.1 to 12.2.6. Actually, see here we have a star. This problem has star. That means this one is difficult, right? Now let's use this one as an example. Try to solve this problem. Now let's say, let a triangle XYZ be an equilateral triangle with set length, that's S. Find a formula for the area of the triangle XYZ in terms of S. See, we already did this, right? You know, in our example, we got this one equals root 3 over 4 times S squared. This is the area of this triangle XYZ. Remember, in our example, we use A, right? Here, use S, so you got this answer immediately. Okay, this is A. Now let's go to B. See, this problem says the circle in the diagram at the right has a radius that's 12. So that means OA equals OB equals 12. And the center O is a center. point A and B are on the circumference of the circle such that angle AOB equals 60 degrees. So that means this triangle is an equilateral triangle. Then they ask you to find the area of the region between non-segment AB and the shoulder arc from A to B. Then they ask you to find the area of the region between this one and this one. So that means ask you to find the area of this shaded part. Okay? Everybody, you can try this. How to do this? This one actually is very easy. It's not hard at all. Let's see who can get this. You can send me your private chat. Let's see. You know, this one I told you is not hard at all. Why? Because after you got this triangle OAB, it's a equilateral triangle. Then they also give you the length of this equilateral triangle, that's 12, right? So they give you this angle that's 60 degrees because OA equals OB. So this angle also equals this angle, right? So 180 minus 60, you get a 120, then divided by 2. So these two angles each also equals 60 degrees. So that means triangle OAB is an equilateral triangle. Then we can get the area of this triangle equals root 3 over 4 times 12 square. Remember? That's root 3 over 4 times length square give you the area of triangle OAB. Okay, you got this. Then you can simplify this one. Say this one would be 36 times root 3, right? 4 and 12. Cancel out 4, then got 3. 3 times 12, 36, then times root 3. This is the area of triangle ABC. Then to get the area of shaded part, you need to calculate this fan, like OAB. This area, this one actually it's 1 over 6 of a full circle, because this one 60 degrees. A full circle, that's 360 degrees. So that means this area is 1 over 6 of a full circle. A full circle area, that's pi times radius square, 12 square, then divided by 6. This one give you this fan area that will equals 12 divided by 6, that's 2, then times 12, that's 24 pi, right? This one, that's OAB is this one. Then you can get that part the shaded part AB, suppose I use this one to represent, will equals 24 pi minus 36 times root 3. Okay, that equals this. Okay, so this problem looks hard, but actually it's not hard at all. You need to just keep trying. Now let's go to section 3. In this section, we'll learn the quadrilaterals. Quadrilaterals, that means a polygon has 4 sides, right? Then the special case for quadrilateral usually it's like a rectangle. You can see this picture, and also square. These two type of figures. It's a special case of quadrilateral, right? Now, like trapezoid is also a quadrilateral, right? Now let's see some example about quadrilateral. Say 12.12. A rhombus is a quadrilateral in which all four sides have the same none. Okay, rhombus is like this. Okay, this is a rhombus. Then you have all four sides. Suppose this one's A, this one's B, this one's C, this one's D. These four sides are equal. Then A is every square also a rhombus? Yes or no? Okay, Sophie, you're right. Who else? Is every square also a rhombus? Yes, because a square, you have a square. Suppose I draw this square here. A square, you have four sides equal, right? Because for square, you have four sides. They're also equal, right? So a square is a rhombus. Now B, is a rhombus, is every rhombus also a square? No. Yeah. So because for if you want to be a square, you also have each angle should equals 90 degree. Each angle should equals 90 degree. If each angle is not 90 degree, then you're not a square. For general rhombus, their angle is not equals 90 degree. If their angle equals 90 degree, then they will be a square. So that means only the rhombus with each angle equals 90 degree will be a square. For all other cases, they are not square. Okay? Now let's go to 12.13. Explain how to arrange 4, 3, 4, 5 right triangles so that together they form a rhombus with a none side nonce 5. So now let's draw a right triangle. Suppose this one is a right triangle. This one equals, this one's 3, this one's 4, this one's 5. So think how you can get rhombus. Use 4 right triangles. Their sides are 3, 4, 5. So this one is very easy. You just do like this. By divided a rhombus to 4 triangles, then you can see here. You can see here, this one's A, this one is B, this one is C, this one is D. Then BD will perpendicular with AC, that's their intersect as E. Then you get this 4 right triangles ABE. This one side will be 3, this one will be 4, this will be 5, this 3, this will be 4, this will be 5, 5, 5. Right? By this way, you can think, you put the 4 right triangles like this way. Put it there together, then you get the rhombus like this. Say this one, put this right triangle here, then put another same right triangle just beside of this triangle, then put another one like this, another one here, then you get a rhombus, right? So now say this rhombus each side, that's not 5. Okay, this is very easy. Now let's go to number 12.14. So this problem, ABCD is a rhombus in which the diagonals have length AC equals 8 and BD equals 12. In this equation, in this problem, we'll find the area of ABCD. Okay, so first you need to still draw a rhombus like here. This one A, this one's B, this one's C, this one's D. Then you connected AC. Okay, then you connect BD. Then they give you AC equals 8. AC equals 8. BD equals 12. Then they ask you what is the area of triangle ABC. ABC, this one. Okay, say this triangle ABC, you know you can set AC as a base. Then suppose the AC intersect with BD at E. Then BE will be the altitude, right? This one will be a right triangle. This one will be a right angle. You know why? Because this side will equal this side. Because all these three sides are equal. Remember how you can get a rhombus from the 4 right triangles? Just the previous problem. Remember, from the previous problem, they ask you how you combine 4 right triangles with side length 3, 4, 5 together to get a rhombus. So then, say for any rhombus, if you draw these 2 diagonals, then you got 4 right triangles. So that means this angle will equals 90 degrees. Then by this way, we can get the area of triangle ABC will equals 1/2 times AC, then times BE, right? Then we'll know BE, that will be 1/2 of BD. So this one equals AC times 1/2 of BD. Because this one equals this. Then you know why. This triangle will congruent with this triangle. So this one BE will equals DE. So you got this one equals 1/4 times AC times BD. So here we get another formula. If you try to calculate the area of rhombus, if you know the length of the 2 diagonals, then you times these 2 diagonals together, then divide by 4. This will give you the area of a triangle ABC. But the area of this rhombus will equals this product of these 2 diagonals, then divide by 2. Because area of rhombus is twice of this triangle ABC. So by this way, continue calculate this one will be 1/4 times 8 times 12. So you got this one, that's 2 times 12, that's 24. So area of ABC, that's equals 24. Area of ACD also equals 24. By this way, we can get a area of rhombus ABCD will equals 48. So then you can this 48 actually equals 1/2 times AC times BD. So AC equals 8, BD equals 12. Time together, then divided by 2. You got this one also equals 48, right? So from this problem, then you can get the area of triangle ABC that equals 24. This one equals 24. Area of the rhombus equals 48. Then remember later when you try to, if you meet this kind of problem, they give you the length of the diagonals of a rhombus. Then to calculate the area of the one triangle, that will be equals 1/4 times the length of these two diagonals. Okay, this gives you the one triangle here. If the area of the rhombus just will be equals 1/2 times AC times BD. Okay, this one is a very important formula to calculate the area of rhombus. So now let's go to problem 12.15. Say find a formula for the area of rhombus with diagonals of length x and y. Say actually we already got this, x times y over 2. This one gives you the area of rhombus. Now let's see 16. Find the area of a square that has diagonal length equals 8 times root 2. Okay, so this one that will be 64. You know why? If a diagonal is 8 times root 2, the length of each side of this square will be 8. You see? Okay. I need to draw a diagonal. Okay, suppose this diagonal equals 8 times root 2. Then to calculate the length, you can set each length equals x. Then you got an equation based on Pascal's theorem. You got x squared plus x squared equals 8 times root 2, then parentheses square. So you got a 2x squared equals 2 times 64. So you got x squared equals 64. That means x equals 8. You know, x also maybe equals negative 8. But this one, you know, it's length of the square definitely cannot be negative number. So x has to be equals 8. So length of this square, each side that's 8. Then area of this square will equals 80 squared. So this gives you 64. This is 16. Now let's go to 17. Parallelogram. Parallelogram, that's another special quadrilateral. It's like this. Usually it's something like this. Okay. Suppose this one is A, B, C, D. Then it's say parallelogram. It's a quadrilateral in which the both pair of opposite sides are parallel. So that means this one parallel with this. You add an arrow, okay? Then this one you can use this arrow to represent these two sides parallel each other. Then now say, is every rectangle also a parallelogram? Yes. Say a rectangle is this. This is a rectangle. Suppose the rectangle, this one is A, B, C, D. Say AB is parallel with CD, and AD is parallel with BC, because all these angles equals 90 degrees. So that means this side parallel with this side. This one parallel with this. So that means every rectangle is a parallelogram. B, is every parallelogram also a rectangle? Definitely is no. The only parallelogram with each side of angle equals 90 degrees, that will be a rectangle. Other parallelograms are not rectangles, right? So this one is finish this one. Now let's go to 18. Say in this problem, we found a math to calculate the area of parallelogram shown at the right. Find a way to cut the parallelogram into two pieces of reassemble whose two pieces to form a rectangle. Okay, so that means what you can do? You can do this way. You can draw this, cut this one, this right triangle from here, then move to here. You can draw that one here. Maybe I can change the color. You can draw this, something like this. Then you extended this one to here, right? So this right triangle will congruent with this one. After you move this one to here, then you get the rectangle. Now B, they ask you explain a method to find the area of parallelogram. So that means after you do this one, suppose this one is A, B, C, D. If you move this right triangle to here, then you get this equilateral triangle. Suppose this one is E, this one is F. The area of this parallelogram will equals area of this rectangle. So area of this rectangle ABEF equals AB times BE, length times width, right? This, suppose that's length, this is width. But this one, for that's attitude for the parallelogram, and also equals area of parallelogram ABCD. This one also equals this. So that means area of parallelogram that's equals base. You can consider AB as base times attitude BE. Okay, this is a formula to calculate. Suppose this one's attitude, this one's base. The area of parallelogram that equals base times attitude times height. Right? Now let's say 19, trapezoid. Trapezoid you have is also a quadrilateral. You have one pair of sides parallel to each other. Let's say this one, ABCD. AB parallel with CD, right? This trapezoid, ZY parallel with WX. Then to calculate the, let's say, if you try to calculate area of a trapezoid, you need also has now let's see, actually you need to use sum of the base. So that's AB plus CD divided by 2, then times height. This is the area of a trapezoid. Okay? Then you can think this one, when you do AB plus CD divided by 2, this gives you the average of this base, then times height. This actually will, when you do the as average, actually that gives you the length, then length of rectangle equivalent with this trapezoid, then times the height. That's actually you calculate the area of a rectangle equivalent with area of a trapezoid. So then now let's see this example 12.20. Say in this one they ask you to find the area of each quadrilateral below. Say this one it's this one give you AB, give you CD. You have this side parallel with this side, so you can consider this a trapezoid, right? So you use 7 plus 9 divided by 2, then times this altitude. So that's 16. Let's see. We'll get this one will be 7 plus 9 divided by 2, then times height. 16, 8 times 4, that's 32. Right? So thumbs up with this one probably is the last one. Yeah, we almost finished this one. So then you can do the left problem. Also, your homework will be all the exercise problems behind this section. So we can stop here. Everybody, bye.